Hi everyone, hope you're doing well. I just wanted to share with you a short video of the solutions for Worksheet 1. So question number 1 that you see there, what is the relative VO2 max of a 20-year-old college-age male who has an absolute VO2 max of 4.1 liters per minute and weighs 192 pounds and is 72 inches tall? And then the second part of this question, based upon this person's relative VO2 max, is this person considered to be fit? So the first step is we have to convert the weight in pounds to kilograms. So we just apply that constant of 2.2 pounds per kilogram. That gives us our body mass in kilograms of 87.3 kilograms. Next step is we have to convert the 4.1 liters per minute to milliliters. So we do the 4.1 liters per minute times 1,000 mLs per liter, and then we take that product and divide that by the body mass in kilograms of 87.3 from the previous step, and that gives us our relative VO2 max of this individual of 47.0 mLs per kg per minute. Now, is this person considered to be fit based upon his relative VO2 max? So going back to table 4.7, something that we utilized in class, looking at the VO2 max classifications by age and sex. And again, this is not a table that I expect you to memorize, but this is a table that you should be able to utilize if you need to. So if we look at, for men in the 20 to 29-year-old age group in table 4.7, we find that a VO2 max of 47.0 would be considered fair in the fair category, and somewhere between the 45th and 50th percentile. All right, number 2, calculate the absolute and relative VO2 of a 35-year-old female who weighs 150 pounds and has a resting cardiac output of 5 liters of blood per minute and an arterial venous O2 difference, or AVO2 difference, of 5 mLs of O2 for every 100 mLs of blood. So this is these calculations here for question 2 are directly from the videos that I posted on Canvas last week talking about the Fick principles. Go back and review those. So first step, just like we did in question 1, convert pounds to kilograms. So we know that VO2 is the product of cardiac output and AVO2 difference. So we have our cardiac output of 5 liters per minute and our AVO2 difference of 5 mLs of O2 per 100 mLs of blood. However, we've got to make sure that the units match up before we can multiply the two. So we take the 5 liters per minute, multiply that by 1,000, because again there's 1,000 mLs in every liter. That gives us 5,000 mLs per minute times 5 mLs of O2 per 100 ml of blood. And that gives us a VO2 of 250 mLs of O2 per minute. Now, if we do some additional math here, we take that 250 mLs of O2 per minute and convert that back to liters per minute. So we multiply the 250 times the 1 liter of O2 for every 100 mil of O2. And that gives us an absolute VO2 of 0.25 liters per minute. So anytime you're reporting absolute VO2, the appropriate units are liters per minute. So now that we have absolute VO2, it's relatively simple to convert that to relative VO2. Again, we take the absolute VO2 of 0.25 liters per minute times 1,000 mLs per liter, divide by this woman's body mass, and that gives us a relative VO2 of 3.7 mLs per kg per minute. So make note in question 2, I'm not asking for VO2 max, I'm only asking for VO2, so oxygen consumption. Number 3, Mark, who weighs 170 pounds, has an exercise capacity of 13 mets. What is his VO2 max expressed as absolute oxygen consumption? So we do our first step again, converting pounds to kilograms. We know that he has an exercise capacity of 13 mets. In order to convert that to oxygen consumption values, we take the 13 METs times 3.5 mLs per kg per minute, which is equivalent to 1 MET, and that gives us 45.5 mLs per kg per minute. I'm asking for his absolute oxygen consumption here. So we're going to take that 45.5 mLs per kg per minute, divide by 1,000 mLs per liter, and then multiply by the person's body mass of 77.3 kilograms. And that gives us our answer here. His absolute VO2 max is 3.52 liters per minute. All right, number 4, the same guy, Mark. He performs an activity that is 6 METs. What percentage of his VO2 reserve is this activity? And is this intensity light, moderate, or vigorous? So we take his exercise capacity minus his resting metabolism, or basically resting oxygen consumption of 1 MET. That gives us the reserve here of 12 METs. So we're solving for intensity in this question here, or basically percentage. So we take that 12 METs, the reserve, times intensity, which we have to solve for. Remember, you have to add back the 1 MET, the resting metabolism. And for this question here, Mark is performing exercise that requires 6 METs, or an oxygen consumption of 6 METs. So if we rearrange the equation here, we have the 12 METs times the intensity that we're solving for. We subtract 1 from the 6 METs on the right side of the equation. It leaves us with 5 METs. And in order to solve for the question mark, we simply take 5 divided by 12, and that gives us 41.7%. Now going back to your guidelines textbook, looking at table 6.1, something that we've looked at many times in class, 41.7% of Mark's VO2 reserve corresponds to moderate intensity. All right, number 5 here. Using VO2 reserve again, provide an oxygen consumption range in mLs per kg per minute that corresponds to moderate intensity for Mark. And then a second part here, how many days per week should he exercise at this intensity, and how many minutes should he exercise on those days? So we know that reserve again, no matter if it's heart rate or VO2 reserve, is max minus rest. So in question 4, we calculated his relative VO2 max of 45.5 mLs per kg per minute. We subtract the resting value, which is 3.5 mLs per kg per minute, and that gives us a VO2 reserve of 42 mLs per kg per minute. So we take the 42 mLs per kg per minute times that lower range of moderate intensity, which is 40% or 0.4. Remember, we have to add back the resting metabolism, so plus 3.5 mLs per kg per minute, which gives us an oxygen consumption on the lower end corresponding to 40% of 20.3 mLs per kg per minute. We have to do that equation, or do that math again, that calculation again, corresponding to the upper range for moderate intensity, which is 59% or 0.59. So we take that same 42 mLs per kg per minute times 0.59 plus 3.5 mLs per kg per minute gives us an oxygen consumption of 28.3 mLs per kg per minute. So that is your oxygen consumption range of 20.3 to 28.3 mLs per kg per minute. So he's exercising at a moderate intensity. So based upon the recommendations from the American College of Sports Medicine and the American Heart Association, all adults should perform moderate intensity exercise 5 days per week and 30 minutes per bout. However, he does not have to perform this 30-minute bout consecutively. He can accumulate the 30 minutes over the course of the day in 10-minute bouts if he chooses to. All right, number 6 here. Kelsey, who is 21 years old, has a resting heart rate of 67 beats per minute. If she only has 3 days per week during which she can exercise, provide her with an exercise prescription, including all aspects of the FIT principle, that meets the ACSM recommendations for aerobic exercise. And a little hint here is to use heart rate reserve to determine Kelsey's exercise intensity. So, in order to calculate Kelsey's age-predicted max heart rate, we take 220 minus her age. It gives us an age-predicted max heart rate of 199 beats per minute. We know that heart rate reserve is simply max minus rest. So her heart rate reserve in this example is 132 beats per minute. So Kelsey only has time to exercise 3 days per week. So that should give you an idea or a hint here that the intensity should be vigorous in intensity in order to meet that 3 day per week frequency. So we take her heart rate reserve times 60% or 0.6, which is the lower end of the range corresponding to vigorous intensity. We have to add back her resting heart rate of 67 beats per minute, and that gives us a lower end for heart rate of 146 beats per minute. That corresponds to 60% of her heart rate reserve. So the higher end for vigorous intensity is 89% or 0.89. So we take the 132 beat per minute heart rate reserve times 0.89. After we do that multiplication, we add back the 67 beats per minute, her resting heart rate, and that gives us an answer here of 185 beats per minute. So overall, we would see here that her heart rate reserve range, would be 146 to 185 beats per minute. That would correspond to vigorous intensity for Kelsey. So she's performing vigorous intensity aerobic activity 3 days per week, and according to the ACSM recommendations, this should be 20 minutes per bout, or 20 minutes per day that she does exercise. And final question here. Laura's VO2 max expressed as relative oxygen consumption is 47 mL per kg per minute. Expressed as absolute oxygen consumption, her VO2 max is 2.89 liters per minute. So the question is, how many pounds does Laura weigh? So we're doing the math here. We take the 2.89 liters per minute, her absolute oxygen consumption. We're going to multiply that by 1,000 because there's 1,000 mLs in every liter. That gives us 2,890 mLs per minute. We divide that by 47 mLs per kg per minute. That gives us body mass in kilograms of 61.5 kilograms. And then all we have to do once we have kilograms, multiply by 2.2 because there's 2.2 pounds in every kilogram. And that gives us our final answer. How much does Laura weigh in pounds? Of 135.3 pounds. All right, so take a look at this video here. If you have any questions, please let me know, and I'll start grading the worksheets here in the next couple days. All right, so continue doing good work in the class, and I will talk to you later.